is going to evolve. Okay, so we recommended you to use the what? Parenthesis when you're writing any expression with the what? Operators. So this is the order of precedence. Lowest order is nothing but what? Conditional operator. Highest order will be having what operators? Unionary plus, unionary minus, negation operator and logical operator, logical not operator. Followed by multiplication, division and modulus. And then followed by what? Addition and subtraction, shift operators. Then followed by what? Relational equality operator. Then followed by bitwise and logical operator. And the lower order of precedence is nothing but a conditional operator. Did you understand this? So with this, we are covering all the operators. You can recall all the operators what we discussed. So using this operator, so we're going to write the examples of the data flow model. What is data flow modeling technique is, or data flow level of abstraction is? So we are replacing the gates by with what? Higher level of abstraction. That abstraction we are using as a what? Boolean equation. So you know that Boolean equation is composing of what? Expressions. Expressions are composing of what? Operands and the operators. You should have a good idea to write a Boolean expression using operators. Okay. So now we'll take a break for 5 minutes. So after the break, we'll start with writing the data flow model. We'll take few examples. We're going to write a programming for the data flow modeling techniques. Did you understand? What is the basic building block for the data flow modeling technique is assigned state. Assigned means what? It is a continuous assignment statement. Why this is a continuous assignment statement? What are the characteristics of the assigned statement is? Continuous assignment statement is always the left hand side of the it may be scalar or vector. At the right hand side should be what? It should be range or a scalar or net data. Scalar, vector, it may be net data type or range data type. It is continuously assigning. So it is computing at the right side and that will be continuously assigning to the left hand side so that it is active mode. Continuous assignment statement is nothing but what mode it is. It is an active mode. You don't understand? Okay. So we'll take a break now. After the break, we'll write a program. I'll give task to you today. I'll ask you write a program for data flow modeling for 4x1 months using the logical equation, or I can ask you to write using conditional operator. Okay, I'll give the question. Based upon that, you should write the program. You can understand. So we'll take examples after the start break. 5 minutes.
किलो घ्यायची ते ढुंडो घ्यायची रखलो आपल्या साईडला घे
एक आला होता म्हणजे बात मांगी रे भैया नहीं समझता दो दो को हिसाब से दे देती वो मैंने पिए वाला पानी दे भाई दो दिन ऐसी
Okay, let us resume the session. Now we'll take up the examples of data flow modeling technique. Okay, let us take examples of data flow modeling technique. Data flow modeling. Now take a first example. Write a program of 4x1 Muxel. 4x1 Muxel using logical equations. Write a program of data flow. Data flow modeling 4x1 Muxel using logical equations. This is a one question. And also the second question also I am going to give. The second question is write a program of data flow modeling technique 4x1 Mux using conditional operators. Using conditional operators. Using conditional operator. Conditional operator. You know how to do this using the gate level modeling technique, right? 4x1 months. How you're doing? Let us remember instead of 4x1 months, you can remember 2x1 multiplex. How you are implementing the 2x1 using gate levels? By using the primitive gates, right? If I talk about 2x1 marks, 2x1 marks, what is the logical expression for this 2x1 marks? So y, I can write y is equal to s naught bar into I naught plus, correct? S naught into I y. So if I write this in the gate level modeling technique, start with what? Module, correct? What is module name is, let us write mux 2x1, then followed by what? Port list. What are the port list are? I can write I naught I1, or you can make it scale vector, correct? I'm going to write I naught I1, S naught, and then output. Then we need to declare this, right? Input I naught, I1 and yes, correct? Output is 1. Output is 1. Now how to write this using gate level modeling? What gate is required here first? AND gate, correct? So what primitive gate I should use? AND primitive. Using what primitive? What is the keyword is? AND followed by, let us take this as gate 1. Gate 1 of what I need to write? First, let us write the NOT gate we need to take. Let me draw the diagram. Right. This is the I naught. I naught is nothing but what? S naught bar into I1. And this is S naught into I1. This I naught and I1. These two are what operation? R operation. This is output 1. Then I need to declare the what way. Here, this is a NOT is, let us take W1. This is what? W2 and W3. While data type is. Correct. Now I should write here what? Y, W1, correct. W2, then W3. So what is the AND operation output is? What is AND operation output is? First AND operation is W2 is output. W2, if I'm taking this is first gate and this is second gate. Or let us start from the first gate is inverter, second gate is AND gate, third gate is AND gate, and fourth gate is the OR gate. Let us go by order, no issues. Okay. First is what primitive I should use? NOT primitive, predefined primitive, NOT gate. So let's take the name is what? G1. Then what are the first what I need to write? Output. What is output is? W1 comma S naught. Then what I need to write? AND primitive gate to off W2 comma W1 comma I naught. Right. Again and gate 3 of what? W3 comma S naught comma I1. Correct. Again next is what? OR gate. Let us take gate 4. So Y comma W2 comma and then end 1. So this is a gate level modeling technique. Correct. Gate level modeling technique for the 2x1 multiplexer. Now what is the data flow modeling technique is nothing but we are replacing these gates by what? Higher level of abstraction. At abstraction we are writing in terms of what? Boolean equation. So that is concisely reduces the code and then you can easily modeling the hardware using data flow modeling technique. Correct? This is a program now I am asking you to do. So write a program of data flow modeling of 4x1 mux using logical equations. Logical equations. Can you write a program to this? So what is a program to this 4x1 multiplexer using logical expression? This is a program I need to write. What is a 4x1 multiplexer? Logical expression for the 4x1 multiplexer. 4x1 mux. What is logical expression is? So you can write y is equal to what? It's not S1 bar, S0 bar, I naught plus, correct? S1 bar, S0 into I1 plus S1, S0 bar into I2 plus S1, S0 into I3. This is a logical equation. Now to draw this using a data flow modeling technique, this expression, logical expression, what operator I can use for this is nothing but. I can use parentheses to group this expression. This is nothing but what? S1. If I am declaring this as a vector, I can write what? S of 1, correct? Not of what? Not of S of 0, correct? Again what? So there will be AND operation in, dot operation is correct. Here I need to write AND operation, correct? Again not of S of 0, AND operation I of 0, correct? Again close this parenthesis. Now here this is what I need to use. Logical bitwise operator, bitwise OR operator or logical OR operator? Logical OR operator or bitwise operator? Bitwise or logical? Logical. You are talking about this. Bitwise operator. Bitwise logical operator. I need to add all these bits, right? I can go with what? Logical bitwise OR. Similarly, how you can write this expression is S of 1, correct? And of what? S of 0 and of I of 1. Close the parenthesis. Again what? Logical bitwise OR operator. Then this is what? S of 1 and operation of not of S of 0 and operation of I of 2. Then OR operation is nothing but what? S of 1 and of S of 0 and of what? I of 3. So this is a logical expression. Did you understand this? Now can you write a program to this? How to write a program using a data flow modeling technique? Module, let us write mux 4x1, 4x1. This is a module name. What are the port list of there? So I write I comma, S comma, Y. Then I am going to declare using vector. Correct. So what are the inputs? Input. How many inputs will be there for 4x1 multiplexer? 4 inputs. I can write what? 3 down to 0 of what? I. Again input. Correct. 1 down to 0, 2 select lines S1 and S0. So I write this is nothing but S. Then output, how many outputs will be there? 1 output Y. This is my port list and this is my port declaration. This is a port list and this is the port declaration. Now after this what I need to do? Now I need to write the data flow modeling technique. So data flow modeling technique is what? Continuous assignment statement. So what is the building block to this is nothing but assign keyword. Assign Y, correct, is equal to what? We need to write the logical expression. So what is the logical expression for this is nothing but not of, correct, not of S of 1, logical AND operation, correct, not of S of 0 and AND operation, what I need to write? I of 0. Then followed by what? OR operation. Correct. Next what I need to write? What is next term is? S1 bar, S0. This is nothing but what? I1. Again OR operation with, this is nothing but what? S1, S0 bar, I2. Again OR operation. Next what I need to write? S1, correct, S0, I3. is nothing but I3. Did you understand? This is expression, logical equation for 4 cross 1 multiplexer. Next, what I need to do? In the module. In the module. This is my design file. Now I need to write the one. Test bench to this. So how to write the test bench? Module, TB, then what are the ranges are here? 3 down to 0 of I, reg 1 down to 0 of S, then wire of Y. This is scalar. Now what I need to do? We need to instantiate, right? Instance the model. Design model. Okay. So what I need to write? Mux 4 cross 1. Then this is putting a DUT design under test of. Here I need to do the port connection. So port connection by order, port connection by name, port connection by default. So then what I need to do? Now I need to generate the inputs. Correct. Set of input I need to generate. Then apply to the design file and collect the output. So that will be done inside the initial begin. So shall I go with the concatenation operator? Today we talked about the concatenation operator. I'm going to use I comma yes. Shall I generate the random value? Random value that will be assigning to what? I and S. Did you understand this? Next, what I need to do? So let me introduce delay. Then I am going to display this. Display what I want to display. I is equal to percentage 0B tab space. S is equal to percentage 0B tab space. Y is equal to percentage 0B. Now what are the arguments I need to pass? I comma S comma Y. Did you understand? Now let me finish. Finish, then end the initial begin, then end the module. End the module. So I am randomly generating the I value. So randomly generating the one S value. So then I am printing this. Correct. Now let us run this. So this is my I. This is I naught, correct? I naught, I1, I2, I3. So what is my select line it is taking this? What is select line is 2 bit to 0. Now it is taking only 1 bit. Let us remove this. 0. Now it will be taking. Whether I am declaring this as a 2 bit, right? 1 down to 0. Select line is 4 cross 1 multiplexer means 2 selections. So 1 down to 0, here I am declaring this as raise 1 down to 0 of S. Sorry, I need to remove 0 here. Select line. Okay. My select line is 0, 0. When it is select line is 0, 0, what it is going to select? I naught. Here, which one is I naught is? Now let us copy this to here. Now this is your S of 0, correct? This is S of 0. This is S of 1. This is 1. I of 0, I of 1, I of 2, I of 3. Since I am declaring as a vector here. 3 down to 0. Did you understand? When this is 0, 0, what it is going to select? I naught. What is I naught is nothing but 1. Why is selecting the 1? Now this is working as what? 4 cross 1 multiplication. Now shall we repeat this for at least 5 times and 10 times? The different values of the inputs and different select lines. So how to repeat this? Using repeat loop. Repeat statement. Repeat. So shall I repeat this for how many times? 5 times. So this is having a multiple statement, so that I should group with what? Begin again. Then I am going to. So whether I end after the finish or before the finish. after the finish. So this end for my initial repeat statement. This end for initial repeat.
अरे सुन ना गया फिर उधर ट्राई करने मिला ठीक नहीं मिला फिर आएगा हमारा पास बोले तो दस पैसा आ
So
गया
this is not repeating 5 times.
आया
Since what happens here, once it is coming to what display, it is finishing it. So where I need to put this finish? After the repeat end. Now repeat the 5 times. Then what I need to do? Finish it. Now you can see it is printing. How many times? 1. Again, this is 2. But why this I value is taking? Let us remove this B. Now I am going to finish. So remove this 0, then I am going to finish. Now this is working as a 4x1 multiplexer. Now let us analyze this output. When select line is 0, 0, what it has to select? I1. Sorry, I0. 0, 1, I1. Y is equal to 0. Again 0, 1, I1. In this case, what is I1? I1 is 1. 1, 1, I3 it has to select. It is selecting the I3. So when it is 0, 1, I1. 0, 1 means I1. I1 is 1. 1 will be selected. Did you understand this program? Now this is a 4x1 using data flow modeling. By writing what logic we are doing is writing the logical equation. Data flow modeling is nothing but replacing the gates by what? Higher level of abstraction. That abstraction we are writing in terms of equations. Logical equations. Did you understand? Now this is the first program. Now can you work on the second program? Now each time if I am running, I will be getting same sort of the result, right? I want to change this result. Then I should include what? Seed, right? How to include the seed? First you declare the variable like x. Then you assign the value of x. Sorry, where I need to declare is this I need to declare in the way. Test bench. X is declared as an integer here. Okay. After initial begin, I am going to assign the value of x. Let assign the value of x is nothing but 50. Now I am going to write the argument to the random is nothing but what? Random of x. For this seed value, it will generate the different randomization. Did you understand? Let us copy this program. So this is a program to the first one. Correct. The first one is data flow modeling 4x1 marks using logical equations. Logical equations. Now can you write a data flow modeling technique? Let us first you write the 2x1 multiplexer using conditional operator. After doing this, then you can go for 4x1 multiplexer. Third one is 4x1 multiplexer. 4x1 multiplexer. Can you write a program to this? First you write 2x1 multiplexer. Write a 2x1 multiplexer. So what is the first line is? Module, correct? TB, then input. How many inputs are equal? 2 inputs. So okay, module name is mux 2x1 of what is the port list of I, S, Y. Then inputs are 2 inputs. I am declaring with the vector 1 down to 0, I0 and I1. Then input, yes, this is scalar, correct. Then output Y. Output Y. Now your input and outputs by default are what data type? Y data type. Correct. Here input is Y, I is Y, again S is also Y, output is also Y data type. But implicitly it is declaring as a what? violated. Now you can write the conditional operator. Using conditional operator, write the logic for the 2 cross 1 multiplex. How to write this? What is the basic building for the data flow modeling technique is assign. This is output variable, output y. How to write the conditional operator to this? Shall I use the square brackets? I mean the parenthesis. First is what? Yes, correct. Followed by what? Question mark. If s is equal to 1, what it has to select? Shall I write this inside like this? I have 1. Or if s is equal to 0, what it is going to select? I have 0. Then in this line, then I am going to in the module. In the module. In the module. Now let us check for the one syntax errors. So there is no errors. So this is using what? What operator? Conditional operator. Conditional operator. Now shall I reuse this test bench? Same one, I'll do the little bit modification of this. Correct? So I'll use the same test bench. Correct? So let us use the same. Here, module TB, this is nothing but what? 1 down to 0. Now this becomes what? Scalar, yes. Then y. If I want to include the random with the seed, I'm using its seed. Then I need to instantiate the design file. This is what? 2 cross 1 DUT. Port connection by what? By default. In initial begin, I'm using the seed value. Here also I'm using I comma x. All remaining things are same. Correct? So I'm assigning I and s value using what? Random. Randomization. Random value is generated, that will be assigning it to the I and s using what operator? Concatenation operator. Did you understand? Now let us run this code. You can see, I'm going to copy the output here. When select line is 0, what it is selecting? This is I0, this is I1. It is selecting I0. I0 value is 0, it is selecting 0. When select line is 1, it is selecting what? I1. What is I1 value is? 1. It is selecting output as 1. So when select line is 0, I0 is 0. Sir, I0 is 1. It is selecting what? Y is equal to 1. Here also when select line is 0, what is my I0 is? 1. It is selecting the 1. Now this is working as a 2 cross 1 multiplexer. Did you understand? Now I need to check with the different seed value. What I have to do? What I need to do? This is a seed of 150. Now if I want to change this value, let us assign some value for the seed x. Now it will generate the different sort of the pole. Did you understand? Are you understanding this program? 2 cross 1 mux using what operator? Conditional operator. This is a program with a conditional operator. 2 cross 1 mux using conditional operator. Now can you do 4 cross 1 mux using conditional operator? Okay, can you tell me the logic to this? Can I modify the same program? This is a 4 cross 1 mux. Here I am going to write module name is 4 cross 1 mux. This is 3 down to 0, correct? Again, this is nothing but what? 1 down to 0. Single output. Now you tell me what I need to write. Conditional operator. Conditional operator I need to write. How to write the conditional operator? So how this 4 cross 1 mux can be designed using 2 cross 1 mux? 4 cross 1 mux using 2 cross 1 mux. Correct? How you can do? How many 2 cross 1 mux are required? 3. 2 stages, 3 2 cross 1 multiplexer. This is 1 2 cross 1. This is another 2 cross 1. This is I0, I1, I2, I3. So I name this is I0, this is I1, I2 and I3. This is 1 2 cross 1. This is 1 2 cross 1. One select line. Let me write the select line here. Output. This is output. Again, in the second stage, I need how many 2 cross 1? 1 2 cross 1. Correct? This is a 1 2 cross 1. How many select line will be there? One select line. How many outputs will be there? One output. Correct? So this is nothing but a mux tree. This is what we call this a mux tree. So we are implementing higher order mux using what? Lower order multiplexer. So where I need to connect the select lines here? How I can configure the 4 cross 1 mux using 2 cross 1 mux? What is 4 cross 1 mux? This is S1 and S0. Correct. This is my output Y. If select lines are 0 0, what it has to select? I0, I0, 0 1, I1, 1 0, I2, 1 1, I3 it has to select. So shall I connect this select line is S0? This first stage of this will be shorted. This is connecting into one S1. Correct? If both select lines are 0 0, this is equal to 0, this is equal to 0, what happens? Your multiplexer. Here it is selecting this input. Here it is selecting this input. Now Y is equal to 1. I0. If S0 is 0, S1 is 1 and this is 0. Now here the second condition is S0 is 1. Correct, S0 is 1. S1 is what? 0. In this case, what it is going to select? This is 0 and this is 1. What it is going to select? Here in this case, I0 is selecting. Here also I2 is selecting. Since this is 1, it is selecting what? I2. Shall I write here, this is S0 and this is S1 then? This is fine. Now it is working according to this truth table. Now in this case, S1 is what? 0. S0 is what? 1. Let me write this. In this case, S1 is 0. S1 is what? 0. What is S0 is? 1. When it is 1 means it is selecting I1 and I3 in this multiplexer. Here S1 is 0 means what? It's selecting this line. Therefore, it is selecting what? I1. Correct? When select line is 1. So when this is S1 is 1 and S0 is 0. S0 is 0, correct? S1 is what? 1. When this select line S0 is 0, in this case it is selecting this line and this line. Correct. But in the second stage multiplexer, S1 is 1 means always it is selecting this one. Therefore it is selecting what? I2. Correct. When both are 1 1. When both are 1 1. S0 is 1 and S1 is 1. What happens? Here it is selecting I3, here it is selecting I1. But in second stage S1 is 1 means it's selecting this line. Therefore, I3 will be selected. I3 will be selected here. So use this logic to model the 4 cross 1 mux using conditional OR, using 2 cross 1 mux. Can you write a program to this? How to write program? So here S of 1, okay, question mark, parenthesis, S of 0, again question mark, I of 3, correct? I of 3, colon what? I of 2. I of 2. Again what I need to write? Colon. Shall I close this? Here I can write the colon. Next. What I need to write here? S of 0. Okay. Question mark. I of 1. Correct. Colon. I of 0. I am 0. Correct. Now I'll combine all this into one more parenthesis. All this I'm combining. Then end with one semicolon. Now this we are writing what? See, when select line S1 is 1, when this is 1 means which one? Now for this is a conditional expression. For this conditional expression, this is a true expression. This is the false expression. When select line is 1, S1 is 1, it is going to what? This true expression. Again, this true expression, it is checking. Again, we are writing inside this expression, true expression, we are writing one more conditional statement. Correct? In this case, S1 is 1, it is coming here. In this case, conditional statement, S0 is 1, what it is going to select? I3 it is going to select. When it is 1, 1, I3. 1, 0, I2. When S1 is 0, it is going to what? False statement. The false statement, this is 0 means what? This is 1 means it is going to select I1. This is 0 and this is 0 means it is selecting what? I1. Are you understanding this? Now the test bench will be the same. Do I need to change the test bench? Here, okay. This is a 2x1 multiplexer I am writing. I need to change this into what? 3x1. Now this becomes what? 1 down to 0. Any other things I need to change? No. Correct. Now this will be working as 4x1 mux. Now, this instantiation name I need to change. This is beauty of what? 4x1. 4x1 mux. Now it is working as a 4x1 mux. Let us copy this output and check this. So select line is 0, 0. What it has to select? I0. So it is selecting I0. I0 is 0. Y is equal to 0. When select line is 1, 1. I3. What is I3 is? 1. 1 will be selected here. If my select line is 1, 0 means what? I2 will be selected. When select line is 1, 0 means again I2 is 1. 1 will be selected here. When my select line is 0, 0 is I0. I0 will be selected here. You to understand. To repeat all, it is repeating, not repeating 0, 1 combination. Correct? So that what I am going to do, let me repeat this for 10 times. Now let us remove this. Now I want to repeat this for 10 times. So that will cover all the possible combinations. So still it is not covering what? 0, 1 is not covering. Let us change the seed value. Let me make seed value 0 and check it. Now in this case, all possible combinations are there. Correct? Now let us copy the result here. Did you understand this program? 4x1 mux using conditional operators so that you can model 8x1 mux. Huh? You can model 16x1 mux using 2x1 multiplexer. This is nothing but your 2x1 multiplexer. Correct? If select line is 1, it is executing this. If select line is 0, this will be executing. Now we have modeled the 4x1 mux using what? 2x1 mux. If this is clear, you can do 8x1 mux also, right? 8x1 mux, 16x1 mux using the conditional operators. Okay, let me give few questions assignment. You can try and get me the program tomorrow. I'll check with everyone. Tomorrow you should show the program to this assignment. Let me give the assignment is. This is third one. So let us take the fourth one. Write a program. Data flow modeling of 4-bit 4-bit full order. 4-bit full order means what? What is 4-bit full adder is? Parallel adder. How many full adders are required to implement for parallel adder is? 4 full adders. If I'm talking about 8-bit, 8 full adders. Correct. So on. If I increase the vector size, I can make this into what? 4-bit, 8-bit, 16-bit, so on. Correct. So this you can use using concatenation. What operator you should implement? This is nothing but using concatenation. Concatenation and plus operator. Plus operator. Okay, this is one program. And the next program is, so write a program of data flow modeling of 1-bit full subtractor. Full subtractor using logical equations. Using logical equations. And next one, the 6th one is write a program of data flow modeling 4-bit magnitude comparator. Magnitude comparator using logical equations. Using logical equations. There is a one question. Is it carry look ahead order done in the digital? Parallel order has been done, I think. Right? Fast carrying orders examples not done. Okay. Okay, you can try and write a program. If you're not getting idea, you can ask me, I'll teach. Okay. So write a program of carry look ahead order, data flow modeling of carry look ahead order. 4-bit, you can take 4-bit. 4-bit carry look ahead order. So you should write today to all these programs. So tomorrow I am going to check randomly to everyone. Okay. You need to show this and then execute this program and show me the out. Okay, bring your laptops. If I randomly ask, to those they have to run this program and explain the logic and then show the out. So this is the assignment. Okay. So if you are okay, what you can do? So write a program of negative edge triggering D flip-flop. Edge triggering D flip-flop. Okay. So write a program of negative edge. You know what is level triggering, edge triggering, correct? Master slave combination flip-flops. So edge triggering flip-flops are quite good than your master slave combination and level triggering flip-flops. Correct. So edge triggering D flip-flop. D flip-flop. Okay. If you know that how to do this, use this negative edge triggering D flip-flop to T flip-flop, toggling flip-flop. Okay. So write a program of data flow modeling of negative edge triggering D flip-flop and modeling technique negative edge triggering D flip-flop. Use this to implement the what? T flip-flop. What is T flip-flop means? Toggling flip. When you know how to use the toggling flip-flop, you can implement the applications of the flip-flop like counters, synchronous counter and asynchronous counter. So use this T flip-flop. To implement 4-bit. So write a data flow modeling of 4-bit. What is ripple counter? How the clock will be connected in ripple counter? Synchronous counter, ripple counter is also called as what? Asynchronous counter, right? Is nothing but asynchronous counter. Asynchronous counter. The clock is feeding into the synchronous counter is the main clock is feeding to the first flip-flop and second flip-flop clock is nothing but previous stage flip-flop output is feeding to the clock to the second stage and so on. You can understand. So you should try all these programs. 4th one to 10th one. Okay, you are not getting anywhere. You should try. Then only you tell me that sir, this is a program I have done, I have stuck here. You tell me the logic. Okay, don't tell me to write complete program. Today you see, understand all the operators of the data flow modeling. So how to write the program to all these assignments. Okay, today we did with the 4x1 mux using logical equations, 2x1 mux using conditional operator, 4x1 mux using the conditional operators. Then implement you can take one more case. I think you have done this in the data flow modeling. This is the one. 11. 1 bit full order. 1 bit full order using logical equations. Using logical equations. Full order, 1 bit full order. So this is 1 bit full subtractor and combinator. Okay, you try all these examples. First you try all the combinational, then you go for T flip-flop, then T flip-flop and 4-bit ripple count. You should write the test design file as well as test bench file. Then you show me the output. Okay. So with this, I am going to wind up the session here. And next session we'll go with few more examples. How to do synchronous counter using master slave combination. We'll take some example and we'll do using data flow. So after that we'll go with again we'll come back to the lower level modeling, that is gate level. Then in the gate level also we'll implement few combinational and sequential circuits. Then after that we'll go with the behavioral modeling technique, higher order modeling technique, okay, which is widely used. That behavioral modeling technique will go after the gate level modeling technique. Okay. We should must try all these programs today. Yes. So now I request all of you to fill the attendance. So online students, any questions are there, you can go ahead. So I request online students to fill the attendance. Okay, let me stop the session here. So we'll continue in the next session.
हेलो सुशीला, मैंने कब किया? अब कितने में चलना है?
मामी आज ही बता
और कितना लीटर लेना?
हमको नहीं पता है, तुम बताओ। जैसे गाड़ी तुम ही लोगे।
कितना बड़ा होना चाहिए ये बताओ पहले, अंदाजा बताओ कितना बड़ा होना चाहिए?
इसमें 2 लाख आएगा।
अरे बताओ, बड़ी है ये साइज, तो साइज कितना होना चाहिए?
साइज सब बढ़िया है, साइज मालूम है।
साइज कौन सा साइज होना चाहिए?
10 फीट
10 फीट कितना होता है? ये प्लग कितना?
मतलब 6 फीट।
10 फीट दिमाग खराब है क्या? 10 फीट के 50,000 का पड़ेगा 10 फीट।
हाँ, तो
क्या करोगे 10 फीट लेके इतना बड़ा?
वही तुम जो कहेगा चाहिए वो
600 लीटर का फ्री मिलेगा वो तो, 600 लीटर का फ्री मिलेगा। 10 फीट समझ रहे हो कितना होता है?
जो कहेगा यही होगा।
250 बहुत है।
ठीक है, जो कहेगा वही सही, बस जो कहेगा वही सही है, हमारे कहना नहीं होगा।
फालतू में इतना बड़ा फ्रिज।
अरे उसमें पानी रखेंगे, ठंडा रखेंगे,